create student.arff file to suggest the better college to the students, those who are qualified in some MSET latest MSET 2020-21 like that. Generate a decision tree for it and formulate classification tools. So here we need to write a ARFF file. Usually ARFF file will be like this. Okay, so nothing but it is like a table. Okay, so here you see I have a table like this. So this is my table and this is my table name student. Okay, so my table name is student. So relation is nothing but student. Relation is nothing but student. My table name is nothing but student. What are the attributes in the table? I have the attributes like inter percentage, MSET rank, college name. Like I am taking means I want to give the attributes like inter percentage here, MSET rank, and here college name, college. Okay, so what is real, and this is real is real time attribute, and these are nothing but categorical attributes. Means here the college name is a categorical attribute. We have to choose the values from these the available values only. Coming to real, the user can give the any real values. So this is I have defined my table name as student, nothing but at the rate relation student, and my attribute names are inter percentage. So how to define an attribute name? So first of all, we need to write at the rate attribute space your attribute name space its data type. So its data type is real for real time attribute, and the college name is categorical. So I have given this one set of values. Now means the skeleton of our table was created. Now what we should do is we need to enter the data. We need to enter the data. So at the rate data, if you give means whatever the fields or whatever the tuples you want to enter in it, what are the rows you want to enter in it, these are nothing but rows. So my inter percentage is 50 and my MSET rank is 7000. Okay, so I'm giving that I am not eligible to some college, so I have given not eligible. Okay, so randomly I have given some values. Here my inter percentage is 55 and 1000, 10,000. I'm also not. Why? Because here inter percentage is very less, 50 and 55. So that's why we are unable to get it. And coming to here, this case 85 500 CB80 for suppose. So my inter percentage is 85%, my rank is 500, and what is the college I am going to get is CB80. Like that, whatever the data points or whatever the data you want to enter, you can enter, but see that how you are defined your attributes. The first one is inter percentage, second one is MSET rank, and another one is the college name. So you should not change the order while defining your values in the data. Okay, so like that you have to create a ARFF file first. ARFF stands for attribute relational file format. Okay, you have to create this file. Okay, like that. Another example, placement.arff. So what is placement.arff means? I want to check who are the students are eligible for placements. Who are eligible for placements? I want to know. So what should I do is, so I want to create a placements table. So at the rate relation, my table name is placements, and what are the attributes I want to take in the placements are. So I want to know about the student percentage and the student backlogs. Why? Because even though if you see the students based upon percentages and our backlogs are checked for whether they are eligible for placements or not. Okay, so eligibility yes or no. Now these are the three. This is my table. In this table, I am taking 3 rows. Sorry, 3 columns or 3 attributes. Okay, so this is my placements table. Okay, and here percentage, backlogs, and eligibility. So one attribute should be always a categorical attribute should be there. Why? Because This is called as the classification attributes. So how to classify this attribute is depend upon other two attributes. Okay. So even in regression or those things, there is a dependent variable and independent variable like this. Always when you are doing the classification, we have to choose that one should be the categorical variable, and the categorical variable decision has to be depend upon other non-categorical variables like real valued attributes. I have entered some data. Okay. Once if you write it, you have to save like .arff file. Suppose it is also a case sensitive. Whatever the table name you are giving here, relation name, in that name you have to save .arff. So once your file is successfully created, which will be stored into the stored somewhere in desktop anyway, and it will show you when you are creating the RFF file, it will shows like a bird symbol. Okay. Then if you stored like if the file is stored with like a bird symbol, then we can say that your file successfully created in ARFF format. So this is you have to do, you have to write on the paper. Once if the paper you have written, just once I have verified it is correct, then you have to start execution. What we need to do in execution is, I'll show you now with the tool. So check for WEKA. So if you type like WEKA, it will show you WEKA with console and WEKA 3.5. It is already installed. It is already installed in my software. Even though if you are doing in lab number 13 and 14, these are already installed. Okay, open this app. So when you open this WEKA, it is a tool developed by some students like you. Okay. So here WEKA stands for, here we can observe Waikato environment for knowledge analysis. Waikato environment for knowledge analysis means there is this board name is WEKA actually. Okay. So like this Waikato environment for knowledge analysis. Okay. So why it is WEKA means it is a native board of New Zealand. So this tool was developed by University of Waikato, Hamilton, New Zealand. They named it is WEKA, like our Peacock is our national board. Okay, like that here they have chosen WEKA as their native board of New Zealand. Okay, here in this tool we have certain applications like Explorer, Experimenter, Knowledge Flow, Workbench, Simple CLI. We have to go with the Explorer. So once if the tool is open, we have to go with the Explorer. So once if you go with the Explorer, here it will shows you pre-process. Pre-process. So in the pre-process, you can check for open file, means where actually your file is existed. Okay. Image. So open file. If you go to open file, already the file you have stored in somewhere else, like a desktop or somewhere else. You can choose that file what you have created. Okay, means whatever you are written on the paper, that the same thing you need to write on the notepad. Okay, so I'll show you here already which are written in. Some files are given as an sample case studies which are available in tool itself. So I'll go to program files. So if you are unable to get it directly, check for program files whether WEKA folder is available or not. If you go to WEKA folder, WEKA 3.8.5 is the version. There is a folder called as data. Go for data. So these are the sample case studies have been given to you. Okay. So like what we do is, I'll open with using WordPad. If you use the WordPad, it will use the clear visualization. So for our understanding, I will take a sample or simple file. So this is the file. So like open any notepad and just type what you have written on the paper, just type it here. Like here, these are already existed files, ARFF files. So exit relation, and my relation name is weather.symbolic. Okay, what are the attributes in the my table are outlook, temperature, humidity, windy, play. Actually, what is this case study is based upon the climatic condition. Shall we suggest the people to play or no? Play yes or no? So based on that, some data has been given to us. So based on that, we have to decide or we have to classify the data, and we have to say that in what are the conditions which are supportable or feasible for playing some game or a sport. So if you see here, all are categorical, means whatever the data you want to choose, you have to choose from these values only. Choose from here only. Okay. So here data means the data you need to enter. So outlook, the first attribute is outlook. So outlook means you have to choose anyone from this. So sunny, overcast, or rainy. So I have chosen sunny. Coming to temperature, I have to choose anyone from this. So hot, mild, or cool. Humidity also I have to choose from higher, normal. Windy, true or false. Finally play yes or no. So here for this condition, whenever the outlook is sunny and temperature is hot, humidity is high, and windy is false, and play is no. Okay, so we can give based upon some conditions by thinking it whether this condition is possible or not, or we can give randomly, uh, take any one of these values. Okay, and once if you save it as ARFF, it is already saved, just like it will show you like a board like symbol as I have mentioned you. So whenever your file is successfully placed in board like symbol, so then automatically we can say that your file is successfully created. Once file is successfully created, directly double click on that, or we can open any of the WEKA. We can open any of the WEKA window and we can open it. So open file, we can do it manually from desktop. We can choose it, or else directly whenever it is your file is looking like a with the board symbol, directly you can double click on that. Okay, so I'll show you here. The file is already created. I want to double click on that. So automatically, whatever the fields you have, all those, whatever the attributes you have, those attributes will be displayed here. So outlook, temperature, humidity, windy, and play. Okay. So here it will give some statistics like what is the outlook? Outlook means outlook is a categorical attribute. Okay. What are the fields in it? So here see here name is outlook, and the type is nominal. Nominal is nothing but categorical. Okay. So what are the categories we have in Outlook? Sunny, overcast, rainy. Like that, what we have in play? Yes or no. Windy, true or false. Humidity, hot, mild, cool. Like that, whatever we have written in this particular attribute, those values will come. So we don't need this right now. Just this is only pre-processing. We have to know what is our relation name. Okay, how many instances we have. Instances are nothing but number of data values. So in the file we have given 14 samples. So out of 5 attributes, like these are the 5 attributes, 5 columns, and we have given 14 records or rows. Okay, so now if you are able to see, this means your file is uploaded successfully into the WEKA tool. Go to the next tab, classify. In the classify, what we need to is we need to choose the some classification algorithm. So choose. These are the number of classifiers. Okay, beige, naive beige, lazy learners, meta classifiers. Okay, some rules we can generate. But here we use usually the standard one, decision tree. So go to the trees. Go to the trees. In the trees, we have decision stump, J48. Sorry, Pubbing tree and J48 LMT, random forest, random tree. Like that we have trees. But J48 is the tree which you use for the training purpose, means like a decision tree. So when we choose the out of trees, we have choose the J48. Here, test options. Go to the test options. Test options is nothing but we are doing. You are taking the training set. You are submitting the training set. You are not supplying the test set, and we are not doing any cross validation or percentage split. What actually these are? When the model is built, if you want to supply a new test set, we can give the supply test set. We are not doing that. And cross validation. Cross validation is nothing but how many folds. Suppose I have thousands of records. How many number of folds I can make it? Okay. So I want to make it as 10 folds. Means each fold consisting of 100 records. Like that we are folding it. Cross validation. Otherwise, percentage split. In training and test split when doing machine learning, we will divide it like 70% for training purpose, 30% for testing purpose. In such a way, we can do the percentage splits. But we will not use any other. We will use only the training set. So check for the option, use training set, and here whatever the attributes you want to work, all those attributes will be displayed here. But what is your classification attribute? Nothing but play. We voting for play, we have to finalize. Okay, so based on that, we have to choose the attribute nominate play, and you need to start. Okay, so here the statistics will come. So once if you receive the statistics, you need to write all the statistics onto your paper. So these are the statistics, and here see how many instances we have taken. Nothing but 14. Out of 14, how many are correctly classified? 100% means whatever the instances we have taken, all those instances are correctly classified. Coming to the kappa statistic, what is the accuracy of the model is in between 0 to 1 according to the kappa statistic. So 1 means your model is highly accurate. Coming to 0.5 and above, it will be good. Below 0.5, the kappa statistic value is 0.5. Then you need to rebuild the model. Okay. So the confusion matrix. You have studied about confusion matrix, like true positives, false positives, true negatives, and false negatives. Like that, these are the general measures, the statistics we need to see, or we need to learn when we are getting the accuracy. So we have true positive rate, false positive rate, prediction, precision, recall, F measure. Okay, and this is some coefficient value, RVC, PRC, and class. Now, so till confusion matrix, so starting from here, you need to identify, you need to write all the statistics on your paper. Why? Because once if you created the ARF file and ran, whatever the observations you need to write. Okay. Ravi Gunjan. Okay, so you need to write this. Once if you written this on your paper, means these are the statistical observations we need to write, name it, and we need to write in our answer paper. So right click on this. Yeah. So in the right click, if you see the option visualize tree. Visualize tree. Yes. Once we click on visualize tree, so it will create a decision tree and it will show to you. So draw the tree. Whatever it was created by the tool, draw the tree on your paper. Once if the tree was drawn successfully, we need to write the classification rules. How to write the classification rules? Nothing but if else conditions or if else rules. Okay. If outlook equals to sunny, and the humidity equals to high, then play equals to no. Like if outlook equals to sunny, humidity equals to normal, then play equals to yes. Like that, how many children are there or how many leaf nodes are there, those many rules we will get. So totally we will get 1, 2, 3, 4, 5. 5 rules will get. So you need to write these 5 rules. So this is we need to do for your internal or external examination. Okay, so if anybody asks about clustering also, the clustering also we can do, but actually we are doing only the classification. We are not doing any clustering. If you want to go for clustering also, check here clustering. Okay, choose the model like simple k-means, use training set, start. So here totally your file was your instances were grouped into two clusters, 0 and 1, two clusters formed. If you want to see the cluster assignments, okay, visualize cluster assignment. So it will shows like a graph here. Okay, so but cluster we are not giving, just we are only giving for